All right, so we're on page 16 here. 1.2, writing rational numbers as decimals. So remember, anything that a rational number is where you have m over n. So we're trying to put that as a 0.123 decimal, blah, blah, blah. So if you have this, turn it into this. That's basically what we're doing today. So if you look on page 16 on the top, it says, hey, remember this form, so it says 3 over 10. How do you write that as a decimal? Well, we know it's going to be 3/10, right? You can actually do, hey, 3 divided by 10, put the decimal points right there. 10 goes in 0 times, make this 30, 10 goes in 3 times, 30, right? You can do all that to figure it out, but you know 3/10 is 3/10, right? You can also look at, they've got another example there, 21/100 equals 21/100, no surprise there. And then they've also got 5 and 323 thousandths. So 5 and 323 over 1,000 equals 5 and 323 thousandths, 5.323. So those are pretty simple, right? Anything that you need to, anything you can do with those, you can just do your long division, or maybe you actually know what they are right away. But it's pretty simple to be able to turn them into something. If you look on top page 18, sorry, top page 17, it's got 3/8. So you just do 3 divided by 8, put your decimal points there, add a 0, 8 goes in 0 times, 8 goes into 30 how many times? Well, 4 would be 32, so 3 is 24, get 6, drop down another 0, 8 goes into 60 how many times? I believe 7. 7 times 8 is 56. 4, drop down another 0. It goes into 45 times. There you go. 5 times 8 is 40. And then, you know, you've got your final answer. There. Done, right? B gives you one more example. We'll do this one in orange. It's got 6 and 2/25. So there's two different ways to do this one. One is you can say, hey, I'm going to do the 2 divided by 25. And eventually you're going to get your answer there. You can go ahead and do that way if you want. Me, I like to recognize, hey, you need your answer over 10 or over 100 or over 1,000, and then you can just write it as a decimal right away. So I look at this and I say, hey, what can I multiply to get 100 on the bottom? Well, I can multiply by 4 over 4. And then I get 8 over 100. So the final answer is going to be 6 and 8 over 100, or 6 and 8/100ths, right? So it makes it pretty simple. You just got to look at this. Can I multiply that somehow to get 10 or 100 or 1,000? If I can, then I can just get that and then turn it into a decimal right away. It's a lot simpler than just doing your long division every single time. Let's look at guided practice. We'll do numbers, let's see, 3 and, no, let's do 3 and 4. 3 is 52 over 40, and 4 is 10 and 13 over 25. So you can go ahead and do that. Oops. You can go ahead and pause this, do them at home, and we're back. So 52 over 40, you have to turn this into a mixed number. It's an improper fraction right now. So 52 over 40, that, well, it goes in one time, and you've got 12 extra up here after the 40, so it's 12 over 40. Now you can stay with this if you want, but something I noticed is that 12 and 40 is not all the way reduced. So maybe if I reduce it all the way down, then maybe I can get it to go where it's going to go all the way back up. So this number is going to be over 100, because I don't want to have to do a long division because I'm lazy. 1 and 12 over 40, well, what can I divide by? This is supposed to be 40. I think 4 over 4 should work. Becomes 3 over 10. Look at that, 1 and 3/10. That looks promising. 1 and 3/10, done, right? This one right here, Should recognize right away. What do we have to do? Well, we don't have to do a long division. We just have to multiply by 4 over 4. 4 times 13 is 52, I believe, over 100. So it's 10 and 52 hundredths. Look on the top of page 18. It says you can also write the fraction. Oh, so this is talking about repeating decimals here. Oops. Excuse me. So if you have 1 divided by 3, well, what's going to happen? You're going to get 0. You'll get 3. 3 times 3 is 9. And you're going to get 1, drop down another 0. You get 10, you're going to get 3 again, you're going to get 3 again, and again, and again, and again, and again. I know that is a 3, I promise. It's going to happen over and over again. So what are we supposed to do with that? Well, that's called a repeating decimal, and I'm going to introduce what's called bar notation here. Your book doesn't really talk about bar notation, but I think it's really important. So if you wanted, you could say, hey, write 3 3s and then keep on going little dots afterwards. What I'm going to tell you to do for these ones, to write as a decimal, is you write the 3 and then you write this bar over the top. It's called a vinculum. You write that over the top, and that is what I want it to look like, what your answers to look like for this. Not this, because that's just lots of extra sloppy stuff. This is technically what it's called. It's a simpler way of representing it. It's less work. Just make sure you write that little bar over the top anytime you have a repeating decimal. So if you look in here, it says use each rational number repeating decimal, use long division and for A and B in the calculator for C and D. Let's pick one of each. Let's do B and let's do C. So B is no calculator and then C is calc. So B, I do 13 over 12. Well, that's going to rewrite as 1 and 1. 12. Can I multiply 12 by anything to get 100? No, I can't. At least not that I'm aware of. So it's 1 divided by 12. Remember, the 1 is on the inside because it's 1 divided by 12. 12 does not go on the inside. Decimal up here, 0. 0 times 12 is, oh, well, that's not going in either, so I got to do 10. No, 12 doesn't go into 10 either. Got to do 100. Should erase this. 12 does go into 100, I believe. Let's see, 12. I think 12 times 8 is 96. 8 times 12, 96. I get 4 here, have another 0, drop it down. 12 goes into 40. 3 times 12 is 36. And I get a 4. Another 0 drops down over here. Oh, look, I'm getting 36. I'm getting 3 again. So that is what it's going to look like. It looks like 0.83, and then the vinculum goes over there. That's going to repeat over and over again, but we just write this vinculum bar over the top. That bar notation, so we know what it is. The calculator for page 18. I left my calculator at school, but fortunately, Mrs. Brunel has the exact same calculator. So cool, right? 82 divided by 333. This is relationship goals, ladies and gentlemen. So we've got, it goes 0.246, 246. So what are the 3 numbers that are repeating that I should write my bar notation over? Yeah, 2, 4, and 6. So 0.246. Bar notation, can't forget that, otherwise it doesn't count, because 246 thousandths is not the same as all this extra stuff afterwards. This is a lot bigger. I mean, it doesn't look very big because these aren't actually big numbers, but it is a lot bigger. You got to write that bar notation on the top there. All right, let's look at top of page 19. It says divide 1 by 11. Well, that's what they had is the, oh, all that stuff is just the stuff that we did on over on bottom of page 18. Sorry about that. But you can look at how to do those ones if you're wondering. On Guided Practice, bottom of page 19, let's pick one of them. I'm going to pick 6 and 8. So 6 is 11 over 6, which is going to be 1 and 5/6. So I have to do 5 divided by 6. 6 doesn't go into 5, so that's a 0. 6 goes into 50 8 times. Oh, wait. Yeah, 8 times. 8 times 6 is 48. 2, drop down another 0. 6 goes into 23 times. 3 times 6 is 18. 2, drop down another 0. Alright, and now I see the pattern. It's 20 times in a row, so I know that the income is going to be over that. 0.83, and the 3 is repeating. That looks familiar, right? Didn't we just have 0.83? Why would we have that for two things in a row? Well, first of all, this isn't 0.83, it's 1 and 83 hundredths, because this 1 is right here. But if we look back to where we got that, this was 1 over 12. This was 5 over 6. So this was 0.083, and this was 0.830. And the reason for that is 6 and 12 are related, right? They look similar. So you're going to have similar things like that. It's not always going to happen for everything, though. If we look at number 7, oh, did I say 7? No, I said I wanted to do 8. Number 8, write it out on your calculator. It says 78 divided by 37. You should get 2.108. 108, dot, dot, dot. It's going to keep on going. So we want the 2.108, nickel them over the top. Cross that stuff out. Don't even include it when you write down your answer. All right, and the day 2 assignment. So we got top of page 20 here. Looking for writing repeating decimals using bar notation. Guess what? I already taught you how to do all that stuff. So day 1, I taught you guys how to use bar notation. That's what I want you to keep on using. You can look it over top page 20 if you want, but all of it should be things that I already taught you. I will say, well, I do want to go through one example, I guess, that they have on here. They have 0.2857 1428 5714. So ones like this on your calculator, it's really hard to tell, hey, where's the vernaculum supposed to go? Where is the repeating? Well, go until you see a 2 again, at least. So 285714. Then do you see that same thing repeated? 285714. That's good. Now, some of these numbers could be rounded later off in here because your calculator will just round at a certain point, but that doesn't mean that it's not still the right thing. So like if your calculator cuts off right here, this number would become a 6 because your calculator is going to round the 7 to a 6. So even if you have the 2, 5, 2, 8, and then this becomes a 6 instead of a 5, that doesn't mean it's not repeating. It just means that your calculator might cut off right there. So this 285714, yeah, it's a really long repeating number, but that is the repeating number. And put this finiculum over the top here. All right, we'll switch over to bottom page 21 here. Suppose you had to compare two rational numbers, 3/4 and 4/5. You want to write each one as a decimal first. So 3/4, 4/5. Well, you can't just say, hey, what do I have to do to multiply by to get it over 100 for each of them? That's what I would do, and then it's easier to turn into a decimal. So here, multiply by 20 over 20 to get the bottom over 100. Here, multiply by 25 over 25. I get 75 over 100, which is 75 hundredths. And here I get 80 over 100, which is 8 tenths, or you can put the 80 hundredths if you want. But the big thing you need to remember looking at is you're just looking at this first thing. 8 is bigger than 7, so this is the smaller, this is the bigger number. It also shows there you can put it on a line graph if you want. I'm not going to require you to for this one. For some of them, it might ask you to use the number line. If that's the case, then I want you to put it on there. But for the most part, this should be all you need to be able to figure out which one is bigger. Top page 22 here. Compare the positive numbers using the symbols less than or greater than. Use the number line to help you. So if I have 11 over 8 and 15 over 11. All right, well, 11 over 8 is 1 3/8, and 15 over 11 is 1 4/11. How am I going to get that? Well, 3 over 8, we actually did that earlier, so it's going to be 1.375. And 4 over 11, okay, we did not do 4 over 11. But the long and the short is you're going to get 1.36 on that, and the 3 and the 6 are going to be repeating. So which one is bigger? Well, you can look and say, hey, this is 37, this is 36. Obviously, this one's going to be bigger, right? They want you to put you on the number line. Hey, here's 0, here's 1, here's 1.36. Maybe here's 1.37. And then you can draw on there, hey, this one right here is going to go right, well, it's going to go about right here actually, because remember this is repeating. And this one right here, 375, oh sorry, this is space 7. It's going to be over here, about halfway between that and 1.38. So it shows where they are on the actual number line. If you look on the next example, when 17 blue bottles and 14 white bottles are completely filled with liquid, the blue bottles hold a total volume of 228 liters, while the white bottles hold a total of 222 liters. On average, which bottle holds less? So we want to know which one is smaller, which one's less. So 17 bottles hold, so 17 blue, we'll do some blue. 17 blue bottles holds how much? 228 liters. And then 14 white. I'm not going to do that in white color for obvious reasons. Holds 222 liters. So they, oh, that's 22 liters. That would be really easy. Otherwise, if we did that. Which one holds less? So we want to know which one holds less what? Less liquid. What's the liquid? So it's this much liter, this liquid over these many bottles. So that's going to tell us, if you do how many bottles per liter, that's not really going to help you. You want to know how many liters are going to be in each bottle. That'll tell you how much is in each one, because you want to know liters per bottle. You want that one to be higher or lower actually, because they're asking you which one holds less. So you got to do 228 divided by 17. Well, 228 divided by 17, I'm using my calculator here. Yes, it becomes 13.41 and keeps on going. It doesn't look like, nope, it doesn't look like that one repeats, but I'm just going to say it's about that. And then this one, we get 222 over 14 is 1 point. Oh, sorry, I just did the wrong thing. I did 22 over divided by 14. That's going to give you 15.85. And it's going to keep on going here. But either way, you know this one is bigger. So the way you finally want to do that is 228 over 14 is what? Greater than or less than? Less than 222 over 14. And the reason we write these actually out here is because this is considered the more precise way. You could say, hey, 13 and whatever left over you have, like maybe it's 3 or 4 over 17, and 15 and whatever it is, 7 over 17 left over to show that it's bigger. But this is the m over n form. Remember that we were talking about m over n where it's at the other one, so that's what they're choosing to keep it as right now. Doesn't really matter as long as you can show which one has more, which one has less. Let's look at the guided practice about on page 22. Let's do number 12. And I'm going to say you can pull out a calculator and use for these ones because this one gets pretty long. So 24 over 7 is what? Greater than or less than 10 over 3. So I'm going to go to a different color here. 7 goes into 24 3 times, so it's going to be 3 and 4/7. 3 goes into 10 3 times, and there's 1/3 left over. You can do a long division on that if you're questioning it. And then 4 over 7 or 1 over 3? Which one is more? Which one is more? Well, you can kind of intuitively tell which one's bigger. 4 over 7, 4 is over the halfway mark to 7, and 1 is under the halfway mark to 3. So actually right there, you don't even need to do the extra work. Sometimes you can logic your way out through that. If you actually do the actual decimals for this, this becomes 4.42857 and that's repeating is greater than 3, and anytime you have it over 1/3, it's going to be repeating 3. If it's 2/3, then it would be repeating 6. The 9s, anything over 9 is also repeating in a similar way, not the exact same way though. If you look on top page 23 now, compare negative and rational numbers using less than or greater than. Use a number line to help you. So we've got -1/8 and -3/16. So you can't use a number line here for those ones. I'm also going to tell you, hey, the most simplest way to logic this one out, get a common denominator. Then you know which one's going to be bigger. We can get a common denominator here. Multiply by 2/2, -2/16, -3/16. I am going to put this on number line because it's negative numbers and those are important. So let's say this is -16/16 or -1. So -1/8 is probably going to be, or -2/16 is probably going to be about here, -2/16 or 1/8, whatever you want to say. -3/16, that's farther back. So we know that -1/8 is, remember, it's greater if it's closer to 0 here. So this one's greater because it's closer to 0. -2/16, -1/8, -3/16. So that's a simple way to logic it out. They do a lot more work there. The work that they're doing, remember, -1/8, -3/16, as they get the actual decimals. So this is -1.25 and -0.1875. And then they put it on the actual decimal line there that you guys can actually see. So 0, -1, and you can tell again, hey, this is 0.12, this is 0.18. Remember, these are negatives. This is supposed to be negative. That negative should be higher up. So the more negative it is, the closer it's going to be to -1. It's not a lot closer. Both of them are both -1 point something, but this one's -1.25, so that one's going to be closer to -1/8 or -1.25, whatever you want to say. And I don't want to write that big number in there, but that's supposed to go right there. Turn over to page 24. They have another example for us there, -56/11 and -17/5. So 56/11, 11 goes into 55 5 times, so it's -5, and there should be 1 left over, 1/11, and -17/5. 5 goes into that 3 times, so it's -3 and 2/5. So they're going to give you all the other stuff on there too, but I want you to actually practically be able to use these things. So this is the tools I'm going to teach you. So I wouldn't pay as much attention to the way they tell you. Sometimes using the number line can be helpful, especially if you're doing negative numbers. But if you've got -5 and -3, you don't need to use the number line for you to say, hey, here's 0, -1, 2, 3, 4, 5. Well, this number is going to go between -1, -2, -3, -4, -5. You don't need the number line, or maybe you do need the number line to tell you this is going to go here and that's going to go there. So clearly this number is greater because it is further this way, further towards 0 on the number line. That's how I want you to do your assignment too. As long as you can show your work to me like this in some way, shape, or form, then I'll accept it. I don't need you to write out all of the decimals for everything. Yes, the section is on decimals, that's important, but the more important thing to me is, can you show me in some way, shape, or form that you understand how these things look like on this number line? What these things look like on this number line. Back of the book will be slightly less helpful when you're correcting your assignment this time, but you can ask me any questions if you have them. Guided practice about page 24. I'm not going to have you do any of those because I think that you know how to do those or one similar to them. You can look at number, let's see here, number 15 in particular can be a little bit tricky because 1/6, you don't know what 1/6 is a decimal. You can quickly figure that out and figure out where those lie and which one's bigger. Number 14, well, look, 41 divided by 5. 40 divided by 5 is 8. Hey, look, you got -8 versus -10. You know which one's going to be bigger. All right, you're good. You can start your assignment.